So yeah, hello everyone. So I didn't make slides, but I can just talk with the paper that I have. So basically, in this paper, we are trying to find ways that can disentangle like reasoning from computation, especially when we are addressing a lot of mathematical problems, right? For example, the current best model at that time was the chain of thought paper, which basically asked prompt the language model to generate like a long sequence of a text, right, which describe the reasoning steps, and then trying to do the computation, right, and then solve the math problem. So one problem that we found, which is super glaring, is that like these models are not particularly good at like doing floating number computation. So if you look at like some of the examples that I listed in the paper, right, especially like for example in Fibonacci sequence, right, if you prompt the language model and then you are asking about like the 50th number in Fibonacci sequence, right? So this chain of thoughts will need to do a lot of computation, and all of this computation are done in the form of like natural language, right? So you can see there are a lot of additions, and then number can be super large, and then the model is pretty prone to errors. And then we were thinking that you know probably like natural language is not the best form of vehicle, right, to do this type of reasoning. And then that's why it prompted us to think deeper in this area, whether we could have a better way of like representing the knowledge, especially in numerical domain. And so it kind of comes to us very naturally that maybe programs is the best the format, right, that we could reason about different types of math problems, right? Especially like in Fibonacci sequence like examples, right? If you turn if you use chain of thoughts, right? If you're gonna explain that in text, you know, you need to have like a few thousand words to explain like the whole reasoning process. But if you transform that into a program, right, and then you have this for loop, right, which can accelerate and significantly decrease the amount of token consumption. And then also when you convert the text into this type of program, the program is can be executed on like a Python executor, right? So the Python executor is super accurate. It basically means that you won't be able to make any computation errors in the middle, right? So therefore, using a program as the intermediate reasoning format for solving like especially this mathematical problems, it has a lot of advantage, right? You know, it's not only shorter, but it's also much more accurate, right? And so that's one type of you know, pattern that we observe. The other thing is that if you want to use natural language to solve a lot of these very complex problems, which require some domain knowledge, right? Especially you are solving a cubic equation, right? So if you're gonna use natural language to describe the intermediate step, it's super long and tedious, right? And language models are not specifically trained to actually accomplish this type of task. So therefore, maybe we could resort to some external library, right? So at that time, SymPy was, you know, like one of the most famous like a program library in Python that can help us solve this type of this type of problem, right? And then we think that maybe we can just let the language model to generate like the SymPy calls, right? Like this type of thing where you have some symbol, right? And then you formulate this into a SymPy solver function, and then the solver function it's implementing some Newton's method or whatever under the hood, but the language model doesn't care about it. And then once it calls this API, it's able to solve this symbol of our interest and then return it as the answer, right? So we found that, you know, this is the second pattern. We found out that like program is a much stronger alternative to language model, to using language to do the intermediate reasoning, right? So we basically move on forward with this idea, right? And then, you know, to use a program as an intermediate, like a pattern or intermediate reasoning step to solve numerical reasoning, like, you know, there are 7 different data sets we consider, right? There are some like math data sets, like GSM, Aqua, Swamp, or so on and so forth, right? So these are normally like grad school math problems or linear algebras or geometry type of problems. And also there are some other data sets like fine QA, confined QA, TAT-QA, which are mostly like financial driven problems, asking about different types of financial problems. You know, these type of data sets require intensive amount of computation. So we think that these are like a very good like evaluation benchmark for us to actually evaluate this idea on, right? So basically, we at that time we tried different types of large language models. We tried so the first one, it's the most natural one, is Codex, right? Codex, it's specifically trained on generating, you know, general form code, right? It's especially good at generating like a common language like Python and so on and so forth. And therefore, we just prompt the language model by giving it like a few demonstration, right? So here, right, so we could just give the language model a few question and program input-output patterns as a demonstration. And then we prompt the language model so that the language model understands that, oh, okay, I should follow this pattern to generate a Python program to solve this problem instead of just using text as the intermediate reasoning format, right? And therefore, we tried. So basically, we don't need to actually tune the model at all. We just prompt the language model to do it, right? So we basically have these are some of these like results that we get. So we have we evaluate our model on GSM 8K, Aqua, Swamp, and so on and so forth. These are the 4 data sets from numerical reasoning, from math question answering. So as you can see, the blue bar is coming, or the purple bar is coming from chain of thoughts, and the red one is coming from program of thoughts, which is our work. And like you can see that our model is outperforming chain of thoughts very significantly on all of this mathful problem data sets. And on this financial QA data set, like the gap is even larger, right? So one thing we do observe is that in financial QA, in a lot of this math QA data sets, the answer is normally like an integer. So the large language models are still okay with that, like computing some integer numbers. But for fine QA, so normally you need to do like floating number computation, and large language models are particularly weak at that, right? At calculating like division of 2 like large numbers and then get the proportion or something like that. We find out that the large language model is doing very poorly, and it's only getting like 40% accuracy. But if you transform that into a program, and then the program can calculate this large numbers very accurately, yeah, with the underlying Python solver, right? And then that's like one experiment that we did, which is like the few shot thing. And then we do the self-consistency decoding, where basically we ask the language model to generate not just one program of thoughts, we ask it to generate like a couple of them, right? Let's say 30 of them, and we execute all of them on Python solver. And then we will get like a lot of answers, right? And then we do the majority vote and then see what are the answers that are occurring most frequently, right? As you can see here, with this idea, it's basically an ensemble idea. We can improve the GSM, alquar, so on and so forth, but normally by 4 to 10% on all the data sets, right? So, and you can also do this ensemble trick on chain of thoughts prompting as well. And then as you can see, with the chain of thoughts, with the self-consistency, we're still performing a chain of thoughts by a very huge margin, especially on this financial QA data sets where you need to calculate very high precision floating numbers. And then we take this problem up a notch, right? And maybe we think that maybe we don't even need demonstration, right? So in here, basically you still need to handwrite a few demonstration of question and program pairs, right? And then try to prompt the language model. Sometimes people are so lazy that they don't even want to write the demonstration. And then we just try to see, is there any chance that we just do this like in a zero-shot fashion, which is give the model, give the model the problem, and then the problem, like the model just going to solve it magically, right? Can we actually do that? It turns out that it's possible, right? And this can be done using prompt engineering. So basically, if you ask the language model in this format, right, where you have like the question and then answer, right? And then you ask this specifically to implement a solver function and then solve this with Python program step by step, right? And then you have this this type of prompt, and then the language model or the codex is able to follow this instruction and then actually generate the answer using a Python program very naturally, right? And then without any demonstration, this is, as you can see here, right? And without any demonstration, definitely the performance is going down a little bit, right? So on GSM 8K or so on and so forth, right? You can see that the performance drops by 10 to 20%, but it's still a pretty reasonable number. And compared to like the chain of thoughts with zero shot prompt engineering, we are getting an even larger gain. So that's basically the overall idea of this paper. And so these are like our overall experimental results, right? As you can see, we're getting SOTA performance on 6 out of 7 data sets, right? And then on zero-shot prompting case, we are able to get SOTA performance on all of the data sets being evaluated. And yeah, and then we also did some like error analysis to see what are the kind of problems that large language model is still struggling on, right? So especially we observed that like for geometric problems, right? And then also for like combinatoric problems, and then probability questions, chain a program of thoughts, like our model is still struggling on top of. So we're thinking that maybe like in the future we could do some more of like engineering to help improve models' performance on these type of data sets, right? So also one thing that I want to mention is that at that time there was no GPT-4. So all these data, all these evaluation results are obtained from GPT-3, like basically DaVinci 002. And then we did some further evaluation recently with GPT-4, and then we can improve the Aqua QA performance to roughly 78%, which is another 20% improvement. While the other data sets, we are almost getting like a full score, like a 90-something% on the final accuracy. It basically means that with the new GPT-4 model, we are actually very close to solving 7 out of all this, 4 out of these 5 mass QA data sets. And yeah, so that's basically the overall ideas here for this paper. And maybe we could move on to more interactive Q&A session right now.
So I had a question. So one thing in this, when you decode the decode, right? So there's a possibility of the program not being generated correctly, right? So do you iteratively decode, or like what's the method that you follow in order to ensure that the program generated is correct and executable?
Executable, right? So that, yeah, that's one of the issue that we have. So especially with the non-self consistency version, right? We are actually generating just one program, and we observe that like for these data sets, right? It's actually very simple data sets. Like I think roughly more than 95% of the programs being generated by the models are executable. Only like a very small portion of the programs are not executable. And the AquaQA is the one is with the lowest executable rates, because a lot of those problems from these data sets are much more challenging. I think the executable rate for this data sets are probably way lower than 90%, probably like in the range of 70 or 60%. And the self-consistency decoding is helping with this executable thing by like a lot, right? So because you are generating multiple programs, we only evaluate, we only do the majority vote on the programs which are executable. So by using this decoding mechanism, we can improve this this aspect by a lot.
Okay, interesting. And also, I think there was this one paper recently, Sparks of AGI. So in that, the authors show that when they use chain of thoughts or any prompts and pass like a instruction like you can use search, calculate, or so on to GPT-4, it is able to generate like those as answers to those problems as well without like explicit, like let's say program of thoughts or any other supervision, right? So do you have any thoughts on that, like if you tried that for this data sets, and what was your observations?
I haven't read that paper yet, so can you share more details in terms of how to do it? Like they use Google search or what?
So I think what they do is when they prompt a model for a particular question or example, they also put it a string that you can use search, calculate for like reaching out or finding the answer. And they don't provide any explicit like search or way, but they just like guide the model to use such key patterns and keywords, and the model is able to now answer the output. Maybe it's doing some sort of internal with retrieval or some other mechanism. But I was just wondering, like, if you tried any such cases for GPT-3, and like, yeah.
You mean like using this as this keyword search over
Yeah.
the internet, right? Yeah, yeah, I think that that's a very valid idea. So I think like Wolfram, right, is one of the most prominent website where you can actually solve a lot of math problems. One potential like opportunity to do this is, you know, like you just transform the this problem right into like a Wolfram kind of language, right, and then make a request to their website, and then their website is going to calculate that for you and then return the answer, right? I think that this idea is also like, yeah, so I'll go to that later. So that problem later. So I basically what I mean is that you know, right now like using the math problems or this program is basically one type of tool, right? So you can view like a search or whatever, all of them as external, as a way of doing external tool use, right? So as long as you can teach the model how you can transform the natural language problem into like a specific domain specific language that can you call specific tools, right? Like you can ask it to, you know, visit like the Wolfram website, or using it to execute Python programs, so on so on and so forth. So even just doing Google search, right? Google search can sometimes also help you do some computations, right? So if you are able to view this as like a tool used to kind of unifies all these different types of variants. And there's a question in the chat. While it's currently limited to math, financial, what other domain do you think can be framed as a program of sorts style data sets? I think this is a very interesting question. So I personally tried, so I have a student working on like migrating this program of sorts idea into answering KBQA, right? So basically you can, so in order to answer knowledge graph question answering, you also need to convert like a language or a question into a Sparkle format, right? Which is also a language that can get executed on some knowledge graph server, and then you'll get the answer out. So I have like a few students doing that, and that's more challenging than the mass QA thing, because like a lot those languages, Sparkle language is not Python, so the large language models are not aware of like the grammar and schema of the that Sparkle language, so it makes a lot of error. So we need to do a lot of post-processing to make sure like the generated Sparkle query is valid. And that's one thing that we try. And the other thing is that this SQL, right? SQL is also a very good like testing bed for this approach, where you can basically convert the natural language into like a SQL query, right? And then you can execute it to that on like the tables using the existing tools like pandas or whatever, right? And then get the output, right? Which is very similar idea to the mass QA data set. I'm not sure if that answers your question. So yeah, and like yeah, Jay, go ahead.
So apart from this, so did you try any other programming languages, or like what was your observations like? How does this like models perform across different languages when you try to convert into programs? Maybe apart from Python.
Yeah, definitely. Yeah, I definitely tried this before. And from my observation, Java, C++, and Pythons are all good. So if you're gonna experiment with these three languages on the program of sorts, you will roughly get the same accuracy. I mainly experiment this on GSM 8K, right? But like as I said, so if you're gonna generate like some domain-specific language, which is barely seen in the training set, like it's giving the large language model a lot of headaches. So one example is the Sparkle language, right? Sparkle language that you use to access the knowledge graph, which contains a lot of knowledge regarding the schema of the knowledge graph. And then the model wasn't pre-trained on this type of queries. So it like once it generates these Sparkle queries, a lot of them are not executable. So yeah, I think one of the challenge moving forward is that if you're gonna adopt this type of program of sorts into your own application, right? Especially if you are, for example, if you are some hotel providers or flight providers, right? You want to use program of sorts to handle the requests to your database, right? And then help the customer book hotels or book flights. Normally, you will have specific functions, right? Like JavaScript functions or special language, right? And that the model was not exposed to before during the pre-training. So one of the challenges that how do you actually make this a large language model, especially like codecs or whatever, to adapt to your specific type of language very quickly and understand like this one thing is the grammar, right? And then the schema and what are the arguments and what are the functions, how that operates, so on and so forth. Yeah, that has been something that I've been working on and thinking about for a while. I feel like you know, if you really want to adopt the codex type of model into your specific application that requires specific type of programming language, I think one easy way is that you could actually train the model with some sort of parameter efficient algorithm, like a adapter, right? So basically, you can train some like 1 or 2 layers on top of codex that can optimize the model on your small set of demonstration, right? And then understand what are the APIs that you are providing. So what are the schemas, what are the arguments, what are the returns of these functions, and so on and so forth, so that the model can better figure out how to call, how to customize towards your own need for your specific application. And let me see, there's a question posted in the chat. Have you looked into backtracking when the program makes a mistake while performing the computation? That's a very good question. I haven't done that, but I think there's a paper from Meta called ART, automatic tool usage or whatever, right? So they basically use roughly the same idea, where they try to prompt the large language model to generate programs, that these programs can make API calls to several different libraries. And then they also use like a human feedback in the loop, right? So if the model is making some mistakes, and they hire basically a human to actually rectify some of the errors, and then try to see whether it improves the performance. I think their observation is that like if you have some sort of human to actually rectify those errors, the performance can be boosted by a lot.
Hello.
Yeah.
Thanks for your answer. I was also I think Jay asked this question, but did you see a difference when you use the program of thoughts for a low-level programming language, and maybe in the low-level programming language it will be the computation will become easier or something? Or have you looked into that?
Lower level language, you mean
like assembly level language, like where you the computation?
Yeah, that's a good question. I personally haven't done that. You know, I guess I doubt whether large language model can generate assembly code. Maybe they could, but it will significantly improve the length of the generation, right, to accomplish certain tasks. Yeah. But yeah, that's interesting. Yeah, it means that you will need less API, right? So all of the stuff you have access to is like some primitive functions, right?
Yeah, that's true. Thank you.
Are there?
Like I wonder if it can be this can be used, LLMs can be used to like convert low level languages to a high level language, human readable languages that can perhaps help in like reverse engineering programs and viruses.
Right. That could be one issue. Yeah, so you will need some helpers that can convert this lower level language into a higher level ones. Yeah. And for the multimodal problem, there's the question raised by Jay. I think I'm particularly interested in that. Yeah, so I'm not sure if you have read this paper called Viper GPT, right? Viper GPT is basically like a model. It's roughly like the similar idea but it's applied to image input, right? Basically, it has a lot of this primitive API. So this primitive API can can serve as a specific purpose of API calls, right? So let me share that paper. I think I opened it up somewhere. You know, so this is one of the most exciting paper that I've seen as a follow-up of program thoughts, right? Where if you have some sort of question, right, regarding an image, right, and then maybe this question can be broken down into a lot of small modules, and these small modules will only carry out a very specific functionality, right? Like maybe this one is this can be implemented with one image recognition module that actually finds the object, right, like a muffin, right? And then the other, it will call again to find the kid, right? And then will return something like how many muffins can one kid have, right? By calling some programs to calculate that, right? And there are some even more interesting cases, like you have two cars, right? And then you want to ask what would the founder of the brand on the car on the left-hand side say to the brand of car on the right-hand side, right? So you basically need some sort of vision recognition model that can actually tell you what are the brands, right? And then, but the vision model cannot tell you who are the founders of these people, right? And then you have to go back to the language model, right? And then do some, not go into the language model, maybe using some Google search, right? To find out who are these, the founder of these people. And then you maybe just call the large language model, what would be, like this founder say to the other founder, right? So the language model can complete this by using a sentence like this, maybe blah, blah, blah. It might say that it has been an honor to be a rival with you or whatever, right? So I think this idea is very interesting, where you basically, break down this image problem also into a lot of small functions that you can be executable, right? So this will make this problem of EQA much more explainable, right? And also you can print out the program trace of how the answer is being generated and so on and so forth. So yeah, I'm personally very excited about this. And and more recently, there's this segment anything model, right? So I'm thinking that you can use that segment anything model as one of the functions, right? And then you can plug in here, and then you can do a lot of vision question answering, like in a zero-shot fashion. Yeah, that's what I'm thinking.
Yes, I think this is definitely an interesting work. So one just follow-up question. I was just wondering, when let's say you try to decode and write programs, right, for the prompts, are there any limitations with the types of functions it uses, or let's say if you define more customized functions? Because your, let's say, particular prompt length or context length would be bounded, right? So then how do you in those cases try to overcome? Maybe in this case it might not be, but yeah, in general.
Oh, so you mean like the number of APIs is bound by some numbers, right?
No. So maybe let's say you have some code base, right, or some functions defined, and you want your program of thoughts to use those functions and come up with a program, right? So I was just wondering, in such cases, let's say where there might be possibility of a program or prompt being more than the context window, right? In that case, how one should go about it, or how we should fragment, or did you try any such cases, or yeah?
Right. Yeah, I think that's a very interesting question. Like, what if you have a lot of APIs, right? And a lot of them, each one of them is super long or something, and then you cannot put them into the same context window. And one thing that I've been experimenting is that maybe you can use the retrieval augmented methodology, where instead of putting all of the APIs into your demonstration, you can maybe write some specification for those programs, and then you can use a BM25 or anything that to retrieve a specific subset of the API, and then choose them as the demonstration for you. And I've been using this in the KBQA project, and it works pretty well. Where basically the Spark code language, the model is not familiar with the Spark code language, and there are a lot of schemas the model doesn't understand. So we basically, if we're going to retrieve from a training set, right, and then find out what are the most similar, most relevant Spark code output, right? And then use those as a demonstration. We can bring up the performance by a large margin. That was my experience for that. I'm not sure if that answers your question.
I think it does answer.
Yeah. And there's a question in the chat. I see something. This for the first time that comes to my mind is, can we connect different algorithms as tools together with programming language that simply quite often. Interesting to connect those things. Yeah, I think this is definitely like the trend, right? And especially like the OpenAI, they have the Chat GPT plugin, right? They can allow the developers to develop certain type of plugins, right? And then the model would be able to call these plugins to do various types of things. And definitely, I think moving forward, I think tool use is basically it's a very elegant way to kind of unify everything, right? So before that, we have like a retrieval augmented stuff, and then we also have Python executions, right, and some other stuff as well, right? So basically, all this type of augmentation can be seen as a tool usage, right? So like a Google search or whatever, basically it's just a tool, right? So you can you can transform this basically into a HTML post or whatever to get the results, right? And the mathematical modeling, right? So like the Python generation, you can also view it as a way of like a tool use, right? So yeah, like also the image recognition thing, where you basically have a lot of small modules that can be executed to get some specific object or visual information from the image that can also be seen as a tool, right? So yeah, so moving forward, I'm very happy to see that like I guess in a few years, there might be a general framework that can unify all of these tools together, right? And then you can basically train a large language model that familiarizes itself with all these different types of tools existing in the world, so that it can basically offload a lot of the work to this API calls, and then make it more grounded and make it more explainable. I think that would be something that the community wants to see, right?
Thank you.
Yeah, no problem. And there's another question, can POT be used for other types of math questions? So math problem may not contain any concrete numbers, only non-variables are given. Please find blah blah. Yes, I think this, like I think there are some of these types of questions where where it only involves symbols. There's no number, and I think there are some libraries in Python that enables that, especially the SymPy library. It actually implements the simplify or like rearrange that type of operation that can be used on top of symbols rather than concrete numbers. Yeah, I think that's definitely doable.
I had a follow-up question to that.
Mm-hmm.
So, like, what do you think the changes should be made for like incorporating integration, differentiation, like to the program of thoughts, like? And another one was like, so one problem can be done in multiple ways, like, and some programs can be like longer, some programs can be lesser. So what like could be incorporated for that to get like a shorter program with best time complexity and all that?
Right. Yeah. That's a very good question. I felt like one thing that we could do is, like a human, like the reinforcement learning with human feedback, right? And so we could use some expert raters to like rate the different programs, right? Even though those different programs all of them return the correct answer, but we can ask human like in the loop to rate those shorter ones with more reward or something like that. I think this can definitely be done. Yeah. You know, with some sort of intermediate rewarding mechanism, right? So you can even come up with some heuristic, right, without human, just calculating how much token you use to generate the correct programs, and then reward the ones with which uses less tokens or something like that.
Oh, I see. Thanks.
Yeah.
I think there was a previous question on whether it is possible that having a program-based data set can lead to more generalizability from the model aspect compared to natural language data sets that are out there. What are your thoughts on that?
I see. So you want to see like a program level generalization across different languages or across different tasks.
So I think there was a question on whether, let's say, if you train or like use some program-based data set for your model, then does that like lead to more better generalization compared to natural language-based data sets that are out there when you compare the model?
Let me see. I'm not sure if I understand your question well. You mean like adding more program-based data sets into the pre-training will enhance the model's capability to generalize to any other kind of task? Is that what you?
Yeah.
Oh yeah. I guess so. Yeah. So I think there is some conjecture that saying that like adding some code generation into the pre-training will help the model to better follow the instruction, right? So I guess there's a thread on Twitter that people posted, and they compare different type of large language model. It turns out that the OpenAI's model is way better than other existing large language models, right? And the one of the glaring difference is that the Da Vinci model was like loaded from the parameter of Codex, right? Codex was pre-trained on a lot of GitHub code, right? And then it turns out that after this step, like the model's ability to follow the instruction increases significantly. But it's hard to validate whether that's actually the case without actually doing like very strict ablation studies or something like that. Yeah.
I think that's correct. Because I think there was also this like instruction tuning data sets as well, right? Which at least shows like models generalization ability, right? That they are able to generalize well, like can follow the instructions. So maybe I was just wondering if like, is it instruction tuning data sets or explicitly training on code? Like which one do you think like tends to benefit more when comparing like approaches such as POT? Like, yeah.
Oh, I see. So you were saying that if you can have more program-based data sets and add them to the instruction tuning phase, is it going to improve the POT or something? Oh, yeah. I guess so. Yeah. I think one of the problems that we observe with POT is that so now the POT like it mainly works with codecs. So if you switch out codecs and then use some other models out there, like for example Llama or the previous like GPT-J or something like that, the performance will decrease a lot. It's not like by 10% or something. It's even more than that. And however, like any model coming from OpenAI is actually working very well. For example, like the DaVinci 002, ChatGPT, GPT-4, all of them with program assaults, they are getting like a very high performance. So I guess in that sense, like adding some sort of code level, like instruction tuning into the large language model will definitely help with POT. Yeah.
Did you notice any specific error patterns like while using POT? So maybe language models have this problem of hallucinations as well, right? So
Yeah. So one thing that I observe is that you can see that like in here, swamp, this is a very easy data set. I basically just, so in order to answer the questions in this data set, you only need to do like addition and subtraction, and probably maybe division and multiplication. You know, you only need these 4 operations to answer like all of those questions. So even that, like even that simple data set, like the POT cannot solve it, or like the current large language model cannot solve it. There's still like a 15% gap towards perfect. And when I look at the output of POT, I found out that like sometimes the model can get confused about the problem, right? So mostly the semantic understanding is one of the issue that actually causes this problem. I don't have a specific example, but basically sometimes the large language model misunderstands what you want to compute and stuff like that, and it causes a lot of problems like that. And yeah, so I think in order to making the model to reaching like a perfect score, there's still like some way to go. I think I experimented with GPT-4 or something on Swarm. It's actually getting like a 90, 94, 95% accuracy. So there's still like a 4% gap until being perfect, right? Yeah, so that's one of the error pattern that I observed. The other one is that like for questions that are more like unseen, or the questions that are very different from your demonstration, the models are not very good at it, right? Especially like at Aqua QA. So this is basically, I think it's a algebra data set, right? And due to the limit, like the length limitation, I'm only able to fit like 8 demonstrations for this data sets. And with this 8 demonstration, I'm not able to cover a lot of like kind of questions, because the Aqua QA questions are so diverse. It covers a lot of knowledge, like linear equations, geometric, whatever. And we found out that the model is able to handle the questions very well if the question can be classified into certain, like a like into a category, like one of the demonstration covers. If it falls out of this domain, right, out of this knowledge that the demonstration presented, and model performance will decrease a lot, right? So as you can see in these data set, 42% of the questions are still mistakenly answered. So which means that it's like this type of errors still happen very frequently, right? So yeah, that's what I'm suggesting, where like the models, it's okay with prompting, you can get decent accuracy, but in order to make it even perform even further, like I think some sort of fine-tuning or adaptation is needed for the model to understand like what are the specific domain-specific math knowledge that you are asking for, something like that. I think with that step, maybe you can bump the Aqua QA data set accuracy by a lot. Does that answer the question, Jay?
Yes, it does.
Mhm.
So also, I think based on the paper that I mentioned, right, like GPT-4, where they had early preview of GPT-4 and they evaluate the model's capability, they find that model is not very good at like planning problems related to planning. So do you
Right.
think like how program of thoughts can fit into those and like maybe help with the same more like navigation and those problems where it requires more planning or agent based?
Yeah, I think that's a very valid point. Yeah. So like one thing that like the current language models or the POT struggles is that what if like your question requires two programs, right? You have to use one program to solve some sort of number, and then you plug in that number into the question and then generate another program, right? And then like answer the final question, right? So this is super hard for the existing model right now. Or there could be some other cases where the program generation is like an intermediate step instead of the final answer, right? So it maybe like you generate two, or maybe you generate like something like a name of some person or whatever, right? And then you still need another round of common sense reasoning to actually get to the final answer. So I think the model is still struggling on top of that. Yeah, I guess to solve this, I think some sort of hierarchical generation would be preferred, right? So you can first generate some sort of skeleton, right, or some high-level code, right? And then you with this high-level roadmap, right, and then you call some sub-modules to realize every step on the roadmap, and then chain them together, right? That will be more effective, I think, in those cases. I think in the ART paper, I think they already did something like that.
Auto GPT and they are also doing the same thing.
Which GPT? Sorry.
Auto GPT and
Auto.
those baby AGI. Yeah,
Yeah,
those self-agent. They are doing the same thing. Like they create a high-level instruction and they recursively call the LLMs.
Yeah, exactly. Yeah, I think that would be something that we need to solve more complex questions, right? So in these data sets, these questions are very simple ones. They just asking about a specific number, right? A specific math problems. But if like in some real use cases for us, right? If we want to plan our trip or whatever, right, to serve our goal, we might need like a lot of round of generation, right? So we need to calculate like what is the flight price and what is the the distance and so on and so forth. There are a lot of programs we need to generate, and then we need to have a very good high-level understanding about how they interact, and then try to make it results or whatever, right? But I think this is but in low level, right? So I think POT still serves as a very good module, right? Small module that help you accomplish a specific task, subtask, right? And if you combine this, integrate this, all these subtasks together, it helps you to solve like even even more grand challenge, right?
I also wanted to ask you that I once read somewhere that when humans think, they are not thinking in terms of like predicting the next token, they are thinking in terms of predict the next thought, like a well systemized thought, instead of like a unit of language. Like the thought of the language is supposed to like represent thought, not be itself, right? And the way we are treating training LLMs as if the language is our thought, like we're training to predict the next token instead of the next thought. Like, can this be like? Do you have any opinions on that?
Right. Yeah. That's very interesting idea. Yeah. So basically, as our human brains is actually working the other way around, where we actually have some sort of high-level ideas, right, ahead of time, and then we try to use language to realize like each of them separately, right? There's like a high level of planning in our human brain, but there ain't too much being done in the language model. So yeah, I think that's one of the overarching direction that we are moving forward. But it's still pretty hard for the large language model to train on that, because any text or any corpus you pull from the web, there is no such like a high level plan, right, associated with that. So what this model can be trained on is still this next token prediction objective. So I guess if you want to have more like human-like planning robot or machine, we need to formulate the data set a little bit more, and then train it with a different objective function to help it, be more aware of the high level planning and stuff like that.
Like I'm not like I wouldn't say I'm like professional in this stuff, so I'm like speaking something stupid. But like, is there any can't you like introduce noise in the latent space instead of like asking the language to predict the next token? Like convert the data set into a latent space and then introduce noise there, and that way like it can perhaps be something like thinking the next thought. For example, in diffusion model, they do this to
Right,
like
right,
reduce its size, right?
Right, right. I think that's a very valid point, where you it's better implemented with diffusion objective, right? You can have like a specific paragraph, and then you add a lot of noise to it, and then you train a diffusion language model to denoise those and to reconstruct the original thoughts, something like that. Yeah, I guess that's a very interesting direction. But I don't think anyone has experimented that in a super large scale yet. There's another question by when would you say that COT is better choice than POT on math problems? Yeah, this is a very good question. I guess, as I said, one of the constraints of POT is that the POT is pretty sensitive to your demonstration. If your demonstration doesn't show how to use those APIs, at the inference time, the model is not particularly good at calling some out-of-domain APIs to do it. So in that sense, but like a language, the COT would probably work better under those cases where the API is basically not given in any of the demonstration, and then the model just degrade to its original format of like using text to do the reasoning instead of like using the API.
So I think like problems which are related to proving theorems or algorithms might be falling into this category.
Exactly. Yeah. Exactly. Yeah. So like in order to prove something, it's hard to wrap them up with API, right? And like in those cases, like using, I think you use chain of thoughts would be a better way. But you can always, interleave COT with POT, right? I'm not sure if you get the idea. Basically, you can ask the model to do like a paragraph of COT, right? And then the model realizes that there is something that I need to calculate, right? To get the number, and then I call POT, right? And then I get the output, right? And then I continue with COT. So in that sense, the model can become more flexible. So, I mean, in the end, I think in order to do very good theorem proving, you need to have like some sort of interleaved COT, POT, right? So it's like us as mathematician proving theorem. So it's not like always by like language, right? So in some intermediate step, those mathematicians need to do some sort of calculation to get some numbers and then see, and then use those numbers as feedback to continue with their proof. But yeah, as I said, like we don't have a very good data set to validate those, like all these mass QA data set and the mass proof data set, they are still like I would say they are kind of lagging behind the language model, so their difficulty level is not enough to challenge the language model. So we urgently need more complex mass QA data set or mass proving data set that actually requires the model to think more, right? And then to do like more this multi-hop reasoning or high-level design or something like that. Yeah, if someone could release more challenging data sets like that, it will be really appreciated.
One question. So do you think is there any scope of using LLMs to augment this data set and make it more challenging? Or probably
You're saying-
that's not, maybe because like LLM still lack with the reasoning ability, right? So do you think that's a possibility, or like still it's far-fetched?
Yeah, I think so. Yeah. One thing that you can basically have a few demonstration and then prompt the language model to generate, this type of complex problem for you. But you still need some human effort to, validate whether to actually provide the answer, right? So as to, verify whether the model output are correct or not. Yeah, but in terms of finding or coming up with these problems, I think language models are pretty creative, or even more creative than human beings.
So like in this attempt to like use LLMs to like create their own data set on which that same LLM can be trained on, like on one hand, like it appears conceivable, but on this other hand, like if you look at the statistics thing, like if the LLMs are learning certain distribution, like pulling from the same distribution isn't going to improve its like ground truth value, right?
Not necessarily, right? So if you read the recent paper on self-instruct, right? So there are a couple of papers that tries to use the language model to distill itself. It still improves the language model performance by a lot. I think, but like in the middle, you need to do some sort of filtering, right? So the model generates a lot of data, but you will have some sort of heuristic to select the high quality ones and then push the model and then feed those high quality ones back into the model to kind of push the model, like the model distribution towards those things which are more aligned with the ground truth or something like that. That could help the model.
So like the a human intervention is like compulsory, right? Otherwise, the thing is that it's the same data distribution. Like you are feeding it to the same data distribution going to have.
Not necessarily like human raters. It could be some heuristic that you defined, right? Like you can search the web or whatever. You can have some sort of automatic evaluation to rate those completions, and then upsample those are getting higher scores according to your automatic evaluation and feed it back to the model. And models still benefit from that. It's something like a reinforcement learning, right? Where you ask the model to sample some actions and output, and then use some sort of automatic reinforcement learning metric, right? And then try to reward those which is more aligned with your automatic metric. And if your automatic metrics are good enough, I think it will eventually help the model improve itself.
I think maybe we can, if there are any other questions or
Yeah, maybe we could comment into this. Yeah.
thank you for this excellent talk and like a very engaging discussion, I would say.
Yeah. Very nice discussion, and yeah, thank you so much for participating and inviting me. Yeah, so it's actually my first talk with Cohere, and I'm looking forward to more collaboration and more discussion in any kind of format.
Sure, I think I would love to have you more as well, and like
Mhm.
looking forward to what comes next in this
Yeah.
area.
Yeah, definitely. Yeah. Thank you so much, and
Thank
I
you.
have to go. See you.